Welcome to EQBloom. Today we're exploring a profound and rapidly evolving area of science, epigenetics, and how it intersects with your emotional health. This is more than just a biology lesson. It's a revelation. The idea that your lived experiences, particularly the emotional environment you're raised in, can shape how your genes behave. We often think of DNA as destiny, a fixed script that predetermines our outcomes. But what if that script had highlighters, bookmarks, sticky notes, and redacted lines added by our environment? In this video, we'll unravel how love, trauma, neglect, and support are not merely physiological influences but biological modifiers. These emotional experiences can turn genes on or off, influencing how we regulate emotions, process stress, and even pass traits on to future generations. This is the science of being human, complex, dynamic, and hopeful. Let's begin. To understand how experience rewires biology, we must first understand epigenetics itself. The term epigenetics comes from the Greek prefix epi, meaning above. So epigenetics refers to changes in gene expression that occur without altering the underlying DNA sequence. These changes are mediated by chemical modifications, most notably DNA methylation and histone acetylation. Let me give you a metaphor. Imagine your DNA is a cookbook. 23,000 recipes inside, each one a gene. Epigenetics is the set of sticky notes, bookmarks, and crossed out lines that determine which recipes are used, when, and how often. DNA methylation adds a methyl group to the DNA, often silencing the gene. It's like sealing a page shut so it can't be read. Histone acetylation loosens the DNA around histones, making genes more accessible for expression, like opening a page to read more easily. So while your genetic code stays constant, your gene expression, the actual behavior of your DNA, can be heavily influenced by life experience. Epigenetics helps explain how identical twins with the same genome can develop different health outcomes when raised in different environments, and it's especially critical in understanding how early life experiences affect mental health. Now let's examine what happens when the environment is stressful, especially during childhood or adolescence. Imagine a child exposed to chronic emotional stress. Yelling in the home, emotional neglect, unpredictability, or outright abuse. The stress hormone cortisol becomes a frequent visitor, flooding the brain and body. Chronic cortisol exposure triggers methylation of calming genes such as those that regulate oxytocin receptors, serotonin transporters, and parasympathetic pathways. These silenced genes result in less emotional regulation, reduced trust, and greater anxiety. Simultaneously, genes involved in threat detection and fight or flight responses, those related to the amygdala, become more active. The brain becomes wired for danger, scanning for threats even when none exist. This can lead to a hyperactive amygdala, fear and emotion center, a shrunken hippocampus, memory and learning, and reduced prefrontal cortex activity. The result, a heightened stress response, poor emotional regulation, and increase for anxiety, depression, and PTSD. And this isn't a temporary glitch. These epigenetic changes can last for decades unless they are deliberately reversed. Here's where things get even more extraordinary and sobering. Epigenetic modifications can be inherited. Research has shown that trauma doesn't just affect the person experiencing it, it can be biologically encoded into the sperm and egg, especially through maternal transmission, and passed down to children and grandchildren. Take the case of Holocaust survivors. Studies have shown that their descendants often carry the same methylation patterns on genes involved in stress response, particularly FKBP5, which regulates cortisol sensitivity. Similarly, descendants of war survivors, famine survivors, and abuse survivors often show elevated baseline stress despite never experiencing the original trauma themselves. This is known as intergenerational trauma. The transmission is not simply behavioral, it's biological. If a parent is hypervigilant due to unresolved trauma, their child might inherit epigenetic changes that make them even more sensitive to stress before they even encounter it. But here's a key insight. Inherited doesn't mean permanent. These patterns can be interrupted, reprogrammed, and even reversed. The story doesn't end with damage, because healing is also epigenetic. Just as trauma and stress can methylate, silence, genes related to emotional regulation and growth, supportive environments can reactivate them. For instance, Oxytocin receptor genes become more active in children who experience secure attachment and touch. Growth factor genes, which support neuroplasticity, are unregulated with consistent emotional support and enriched in learning environments. Anti-inflammatory gene expression improves in people who engage in mindfulness, yoga, and deep breathing, reducing epigenetic markers linked to chronic disease. Neuroplasticity, the brain's ability to change and rewire, works in tandem with epigenetics. Together, they say healing isn't just possible, it's biologically programmable when the environment supports it. Therapists, teachers, parents, and even peers, everyone who offers predictability, compassion, and regulation becomes part of someone's healing genome. Let's get specific. What are the tools that can help you epigenetically heal? Number 1, therapy, especially trauma-informed methods like CBT, cognitive behavioral therapy, rewires negative thought loops. EMDR, eye movement desensitization and reprocessing, helps reprocess traumatic memories. Number 2, movement and exercise activates BDNF, brain-derived neurotrophic factor, which enhances learning and reduces fear responses. Increases HDAC inhibition, which promotes gene accessibility, a key mechanism for memory reconsolidation. Number 3, nutrition. Omega-3s, antioxidants, and folate can influence DNA methylation patterns and reduce inflammation. Number 4, sleep. Essential for DNA repair, neural pruning, and emotional reset. Chronic sleep deprivation impairs gene expression in over 700 genes, including those regulating immune function and stress. Number 5, journaling and expressive writing. Studies show expressive writing can downregulate genes involved in stress and upregulate immune function. Yes, writing changes biology. Number 6, safe relationships. Social connection regulates vagal tone and increases oxytocin, reversing fear-based epigenetic changes. Put simply, your daily choices, relationships, and mindset aren't just physiological tools. They're biological interventions. So let's bring it all together. Your DNA is a script, but epigenetics is the director, and the director takes cues from your environment. If you grew up in chaos, fear, or isolation, your biology may have adapted accordingly. But the good news is that same biology is capable of adapting again, this time for healing. You are not broken, you are being rewritten. That's not poetic metaphor, that's molecular truth. And it means you have more power than you think. You can choose environments, practices, and people who turn your healing genes on. You can raise your children in ways that interrupt trauma instead of continuing it. And you can understand yourself not as flawed, but as someone whose biology is trying to survive a story it didn't choose. So reflect on this. What emotional environment are you cultivating for yourself and for others? If you want to keep learning about how neuroscience and emotion intersect to create real lasting change, subscribe to EQBloom. We're here every week helping you understand your brain, your biology, and your potential.